So we will be talking about the mixing, placing and handling of concrete. Placing and handling of Portland cement concrete, or PCC. And then one of the topics that we need to focus on is the batching process. So batching is basically getting different materials from, or with different proportions from the stockpiles or in the batching plant, and then mixing them together to form our Portland cement concrete. So the process of the process is called batching. So the process of measuring proportions of components of PCC components and transferring them to the mixer, to the concrete mixer. And the batch plant is usually where we mix all the ingredients together and have the ready mix. We call it the ready mix batch plants, and then we have them ready for transferring to the job site. And usually the mixing process is by weight, and we're going to talk about this in the mix design process again. But the idea behind using the weight batching is that you don't need to worry about the air voids, right? So eliminates the effect of air voids. Okay. And then once you batch all the materials, once you take all the, for example, you know how much gravel you need, you know how much sand you need, you know how much cement and water and so on. So that's the batching process. And then once you know and you collect all these materials, you need to mix them together, right? So the mixing process. So you need to mix until reaching uniformity, right? So until uniformity. And you make sure that you have a uniform and mixture of all the materials together. And sometimes you can use batch mixers. That you mix the materials in different batches and different quantities, but most of the times, or sometimes you have continuous mixing for bigger plants, right? And what they do is they usually start by adding 10% of the water in the mixture, right? So usually starting with 10% of water in the mixer. Then you add 80% of the solids. I'm sorry, so then 80% of water with solids. So after that, you add solids, followed by 80% of water, and then you mix the remaining 10%. Because and the reason is that you don't want to add all the water all at once, because you want a consistent and uniform mix, and you want all the solids and powder and the cement powder and any other types of powder in the mix to be mixed with all the other ingredients, and water can cover and reaction and create a reaction, chemical reaction with the concrete, with the Portland cement. So that's why we are adding the water gradually to the mix. Okay, so again, the types of the batch plants, we usually have central batching plant that you create or you produce big quantities of concrete in the plant, and then you transfer with the ready mix concrete trucks to the job site. And then sometimes you have mobile plants. So if you're in an area, in a remote area, that you don't have access to a central batch plant, or the transportation cost is too much, that it doesn't make sense to transfer all the materials from the central batch plant to the job site, you can create one of the mobile plants near the job site to produce your concrete. And then the types of mixing, we have, most of the times we have ready mix concrete, right? So ready mix concrete. That's the type that you mix in the central plant. So mixed in the central plant. And transferred or delivered in truck or ready-mix trucks. You've seen these trucks on the road, the big trucks that have a giant mixer, and they are continuously mixing and rotating the mixer to make sure that the concrete is still ready for the construction. Okay, and then we have another type. It's called shrink mixed. So shrink mixed. This is the type that you partially mix the concrete in the plant, and then you deliver in the mixer truck. So partially mixed. And then delivered in in a mixer truck. Now, this type of truck is rotating at a pace of 4 to 16 round per minute. This is round per minute. And then this type of truck is only rotating at 2 to 6 round per minute because it's already mixed, completely mixed. And then there's a third type that is called truck mixed. That in this type, you completely mix the materials in the truck. So mix completely in the truck. And this, in this case, you need 4 to 16, again, round per minute for the mixing truck. And there's a rule that you need only maximum, or you have maximum of 90 minutes from the start of mixing, from when you mix the materials in the plant, to when you discharge the materials. Otherwise, your concrete starts to set and you don't have the enough workability in the job site to place the concrete. Okay, so that's pretty much all we need to know about the batching and mixing. And then we will be going to talk about the sampling and testing. Okay, so sampling and testing. And this is important to do the quality control and quality assurance. You want to make sure that the concrete that you're mixing is according to the specifications and according to the design, both in the plant, in the mixing plant, and also in the job site when you place the concrete. So you need to take samples at the job site. These are the cylindrical samples or cores that you take out of the hardened concrete, or fresh samples from you basically pour or get a sample from the fresh concrete and pour it in a cylinder mold and take it to the lab. Or if it's already hardened, you just take a core out of the hardened concrete. There are other tests to do on the site. So tests on the site. That you need to do the slump test. We talked about the slump test, that you pour the concrete into a slump cone and you release the concrete to measure the workability and see how much slump you have. And also you need to take the air content. So air content is very important in the concrete, and it's specified, there's a specified range in the design and also in the specifications that you. And then you need to prepare samples for later testing. Okay, so this is the type of sample that we need to prepare in the lab, the cylindrical sample, and also we need to create or take samples for a beam sample that we, so either for cylinder or beam samples. That you need to, you have the mold and you take the fresh concrete and take it to the lab for future testing. All right. Now we talked about the slump layer, the slump test before, and sorry, in the course notes you should be able to see the process for doing the slump test that we need to follow. But there's one other test that we probably didn't get a chance to do in the lab. That's measuring the air content of the fresh concrete. So air content of the fresh concrete. And what we do is we measure, with this test, we measure, or this test measures total air content. So total air content. Which is including the entrained air content and capillary air content. And there are different methods to do this, and there is a pressure method. There is a volumetric method. The gravimetric method. And also the chase air indicator. And most of the time the most regular test is that there is a container that you pour the fresh concrete inside, and there is a lid that you put on the container, and there's a pressure meter on the container that measures there are clamps to secure the container, and this one measures the air content, measures pressure. So I'll put a picture of this test right here so that you'll see this is air content test. So that you'll see how we do this test. And then once you take the fresh samples, if you remember here, say that most of the time we need a cylinder, right? And there's a standard, so for cylinders, there is a standard dimension of the cylinder. Most of the time, the standard dimension is 6 by 12, 6-inch diameter by 12-inch height. This is the standard. This is the standard dimension. But most of the time, or sometimes, some labs are also using smaller samples that are 4 by 8, 4-inch diameter by 8-inch height, and there's a correlation between so there's a correlation between small cylinder and larger ones, or the standard cylinder. Right? So what do you do with the cylinder? You fill the cylinder in 3 different lifts. So the first 1/3, this part of the process is similar to the sum test. You fill 1/3 of the cylinder, and you rod it 25 times to make sure that no air clumps or are forming in the concrete, and you're distributing the concrete all over the cylinder evenly, right? So 1/3 of the height, and then you rod for 25 times, and then you do the same thing for the second lift, rod for 20, so second lift, you do it again, rod for 25 times, and then you do it for the last one. That's the third lift. And you do the same, the rodding 25 times. Most of the time, the curing process includes putting the sample in a controlled temperature and in controlled humidity. And that most of the time includes putting your samples in water bath. So put all your samples in water. This is water with controlled temperature. And there's a standard ASTM process for the curing. So ASTM for both sampling and the curing process that we need to follow to make sure that we are following the standard process. And then once you do all of these, you can go ahead with the placing of the concrete. So placing of concrete. There are some notes to consider during the placing. That the height that you drop the concrete, it should be, so drop height should be less than 3 feet. You also need to limit horizontal movements to avoid segregation. And segregation is the process of when the aggregates are starting to separate from the paste. And then when you're building a high-rise building, or you need to reach a high level structure that you don't have access directly from the mixer, you need to do the concrete pumping, and there are a lot of standards for pumping of the concrete, and you need to adjust the mix specifically for pumping, because that requires a different level of workability and a different probably types of admixtures that you need to add to the concrete. So you need to adjust the mix design specifically for pumping of the concrete. And then one of the biggest steps in placing of the concrete is vibration of the concrete. So vibration of concrete. And you do this to consolidate or compact before initial set. So we have two times of setting: the initial set and the final set. The initial set is when the concrete starts to harden, but it has not reached a higher strength level, and it is still workable, but the workability is already reduced a lot. So before that process, or before that stage happens, you need to make sure that the concrete is vibrated or is consolidated or compacted to get rid of those big pockets of air content in the mix, and also make sure that the concrete is covering all the areas around the rebars. So if it's a manual vibration. It's either by tamping or ramming the concrete surface. If it's a mechanical method, you need to perform the process between 5 seconds to 2 minutes in one spot. And usually it's for each spot it's less than 10 seconds that you place the poker or the internal mechanical system into the slab or into the area that you place the concrete, and then you move to another area. And we also need to make sure that we are avoiding segregation. And we want to make sure that we are reaching the entire depth. So that's pretty much what we need to know about placing of the concrete. And then the last step is to finishing the surface. So finishing concrete. And that includes the process of smoothing the surface. With the desired texture. That's we call it desired texture because sometimes you need a very smooth and shiny surface. For example, if it's a parking lot, you need a smooth surface, and sometimes you need a rough surface. For example, if it's a pavement surface, you need to have some level of roughness at the surface. And sometimes if you look at the concrete bridges, you see imprinting on the surface of the finished concrete. That's happening at the finishing process. So also the imprinting in most of the exposed surfaces, you can do that. And this must be done before the final set process. So must be done before final set. And sometimes you can also stamp the concrete surface after finishing. So you probably think that this will be the last step in the process of placing the concrete, and you think you're done with the process, but it's not. Probably the most important process happens after you finish the concrete surface, and that's the curing process. So curing curing process. That means that once you're done placing the concrete and finishing it, you need to maintain a level of humidity at the concrete surface to make sure that the hydration process that needs water throughout the process is still running, and you are reaching the maximum strength several days after the initial placing. So the curing process includes maintain moisture and temperature. So maintaining moisture and temperature in the concrete to promote continued hydration. So that's exactly why we do the curing process, to make sure that the hydration and strength gain process is happening and being completed. So the effects of curing is that if you do the curing correctly, you can make sure that you have enough durability. You can also make sure that you're reaching the strength level that you were designing for, the water tightness. And also the resistance for abrasion. So abrasion resistance. Also the volumetric stability, you can make sure that your concrete is not going to shrink because of the lack of water or humidity during the curing process. So volumetric stability. You also can make sure that you have resistance to freezing and also thawing process. If you do the curing correctly, and also you can make sure that your concrete is resistant to de-icing chemicals. De-icing chemicals that cannot harm your concrete surface, right? Why we do the curing? Because again, the concrete strength is gaining strength over several days. Usually the standard process takes 28 days to be completed. So your concrete takes almost 28 days to reach the 95% of the maximum strength. There's a graph that shows different levels of curing and at different ages. So I'm going to insert this and post it on in the notes. So this is the compressive strengths of PCC at different ages. And curing level. And there are different methods methods for curing. You either maintain a certain level of temperature, a certain level of water presence in the concrete. So maintaining water presence in the concrete. Also, it includes sealing of the surface. Of the concrete surface, and sometimes it requires heating and adding additional moisture. In specific criteria, in specific conditions, you need to maintain a certain level of temperature, and also during the curing process, you need to add moisture to the concrete to make sure that the curing is happening. And you've probably seen this that most of the times after they place the concrete, they either cover the surface, the whole surface, or they spray it with water. Those are the different approaches that they do to maintain the curing process. Okay, so that's the last step, that before you have a hardened concrete. And once now, let's say after 28 days, you have the hardened concrete almost gaining its complete strength. Now we need to know what to do with the hardened concrete. So properties of hardened concrete. Now, there are different things happening to the hardened concrete. The first thing is that there's a volume change, so early volume change that is happening to the concrete, and there is a shrinkage process. There's a creeping process. The permeability of the concrete changes during the process, and also there's a stress-strain relationship. That we need to make sure that we know of. So let's talk about the early volume change. So early volume change of concrete. And I guess we can stop here for today.